Okay, we're in college algebra and we're looking at section 1.6 today, other types of equations and applications. We have three main kinds of equations in this section. And here we are, we're looking at rational expressions. Rational, the root word there, ratio, which means you're comparing numbers by division. So a rational expression could be something like this, 1 over 3x. This is a rational expression right there. We're going to have equations that have those. Then we're going to have radical expressions. A radical is like if you have a variable like 2x minus 1 inside a radical. We're going to have equations with those. And then rational exponents. We're going to have a variable that has a exponent that's a ratio or a fraction. So these are the three main things we're going to be looking at in this section. Okay. First thing, we're looking at some terminology. A blank is an equation that has a rational expression for one or more items. That's a rational equation. A rational equation could be something like this: 1 over 3x plus 2 over 5x equals 6. This is a rational expression, there's a rational expression, but then here's the equals, which makes us have an equation. Right here. Number 2, proposed solutions for which any denominator equals blank are excluded from the solution set of a rational equation. This is 0. We cannot divide by 0, and that's what this is referring to. Let me show you this real quick. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3. 12 divided by 12 is 1. Okay? Now, over here, what's 12 divided by 0? What does that equal? Okay, when you have division, math always has inverses. And so what I can do is I can go backwards on this. So like if I take this 6 times this 2 right here, 6 times 2 is 12. Same thing here. 3 times 4 is 12. 4 times 3 is 12. 12 times 1 is 12. Okay, well over here, what number times 0 is going to be 12? What number times 0 will give us 12? There is no number. And so this is a problem we have in mathematics, that there's no such value that does this. And so we just say in mathematics, we cannot divide by 0. We just don't do it. Cannot divide by 0 because it doesn't work out. We don't have our inverse here. It doesn't. All these others see work, but this won't work. There's no number times 0 that gets 12. So we don't do this. So any value that makes division by 0, we just have to rule it out. We can't have that value. So that's what this is saying here. Proposed solutions for which the denominator equals 0 are excluded. We can't have those solutions. Let's go down to number 3. If a job can be completed in 4 hours, then the rate of work is blank of the job per hour. If it takes 4 hours to complete a job, then that means in 1 hour, how much of the job will you get done in 1 hour? 1/4. You'll get 1/4 of the job done in 1 hour. What if you have a job that takes 6 hours? It takes 6 hours to do a job. How long will it take for you, or how much of the job can you do in 1 hour? Well, you can do 1/6 per hour. Okay, so this is something we're going to be using here with these rational expressions, rational equations. All right, so here's a rational equation right here. Now, what this is asking here is what would be the first step we would do? And this is what we're going to do now. we look at our denominators of this rational equation. We've got a denominator of x here. We've got a denominator of x plus 5 here. So to solve this, what we want to do is just get rid of our denominators. So what I would do on this, I would multiply both sides by x and x plus 5. X and x plus 5. I would multiply both sides by right here, A. I would multiply each side by this right here, and what that will do is that will get rid of the denominators, and then we can solve just a normal equation. Okay, we'll do one in just a second. Here's another question, number 5. What values of the variable cannot possibly be solutions? Now we're talking about this dividing by 0. We have two denominators here. Neither one of these denominators can be 0. All right, so what we do is we take this one here, 3x plus 5. We set it equal to 0 and figure out what x would have to be, and that would be excluded. So I would solve this, so I would minus 5. So 3x equals negative 5, and then I would divide by 3. This will cancel, and negative 5/3 is my 0. So x cannot equal this. Negative 5/3. X can't be that right here. Now on this one, we got x minus 1. Okay, so I would add 1 to solve that. X equals 1. Well, x cannot equal 1 because that's going to make us divide by 0 there. So these two values right here, x cannot be those values. Now finding these zeros can be a little easier than that. Let me show you 2x plus 3 equals 0. Show you a few examples here. Let me do this one again. I'm going to minus 3 on both sides, and that'll cancel out. So I have 2x equals negative 3, and then I divide by 2. X equals negative 3/2. That's what x cannot be in this case, if that was a denominator. Okay, to find these, let me do this again. All you simply have to do, if you have this expression here, to find the 0 of it, you're just going to subtract 3, and you're going to divide by that 2. And there's your 0 right there. So instead of doing all this, you can just do that right there. Okay, you're going to subtract 3, and you're going to divide by 2. Here, I'll just make up a few. 5x minus 1, 4x plus 7, 8x minus 3, 9x plus 4. Okay, here's a few examples. What would my zeros be for each one of these? All right, so on this one, I'm going to add 1 and divide by 5. So it's going to be a positive 1 divided by 5. Right here, I'm going to subtract 7, so negative 7 divide by 4. I'm going to add 3, divide by 8. I'm going to subtract 4 and divide by 9. And so here's my 0. So it's a lot easier than doing this each time. You could just do this little shortcut method. Positive 1 divided by 5. Negative 7 divided by 4. Positive 3 divided by 8. Negative 4 divided by 9. Okay? So yeah, back to this problem here, that this was right. We got negative 5/3 and 1. These values cannot be part of our solution set because that makes us divide by 0. All right, now, so on this one, okay, what values cannot possibly be solutions here? All right, so right here, we're going to do add 3, divide by 1, so it's going to be a positive 3, right there. Right here, we're going to subtract 2, divide by 1, so it's going to be negative 2, right there. And this, now usually when we have these, we have a trinomial like this with 3 terms, trinomial. Usually, if you multiply these two, it'll be that one, and that's the case here. If I multiply those two, I'll get this. So this has zeros of 3 and negative 2. So there's my zeros, and so these have to be excluded. We cannot have these values of x because that's going to make us divide by 0. Number 7 here, same kind of situation. Without actually solving this equation, list the possible numbers that would have to be rejected if they appeared as potential solutions. Well, right here, this is just 3x. Look here, 3x, but there's no number, so it's plus 0. So it's going to be 0 divided by 3, which is 0. So x can't be 0. And here, same thing, 0. And there's no variable here, so we don't have to worry about that one. There's no variable in it. So x can't be 0. Okay. Here's another one. Same thing, I believe. I don't know. We're looking for the solution set now. All right. So let's do this one. So I have 2x plus 3 over 2 minus 3x over x minus 3 equals x. We're going to solve this equation here. Now, first thing we have to notice, what values must be excluded. So like right here, there's no variable here, so we're good on this one. Well, here's a variable there, x minus 3, so I'm going to add 3, divide by 1, that's just 3. So over here to the side, x cannot be 3. Okay, so I'm going to keep that in mind. X can't be 3. So if for some reason we solve this and we get 3 as the solution, then that means there's no solution because we can't have 3, because that's making us divide by 0 right here. All right, so see my denominators, 2 and x minus 3. I need to multiply both sides by that. And I kind of wrote this in the way over here, but so I'm going to multiply this by 2 and x minus 3. And over here, I'm going to multiply this by 2 and x minus 3. Okay. And this is kind of in the way, but that's all right. We'll just work around it. All right, so when I multiply over here, I got to distribute this thing. So I got to multiply it to both terms here. Okay. When I multiply here, this times this, well, the 2's will cancel. So this 2 will cancel this 2. I'm just going to not really mark it out because we have to do it here. I don't want to forget it over here, but the 2's will cancel. All right. So that means I have x minus 3 times 2x plus 3. All right, so let me just come up here and I'm going to multiply that out. I got x minus 3, 2x plus 3. So I'm going to multiply them with this little box. So remember, the 2's cancel. So I have x minus 3 times 2x plus 3. So if I do this up here, this is going to be 2x squared. This is going to be negative 6x. This is going to be 3x. This is going to be negative 9. And these two go together. So that's going to be 2x squared. Negative 6 plus 3 would be negative 3x. And then negative 9. All right, so that's what I get when I multiply these. So there you go. There's what this is. Minus. Now I'm going to put parentheses here because I'm minusing whatever this is. And I got to multiply this times that now. So when I do that, the x minus 3's cancel off. So I've got the 2. Now the 2 is back for this term. See, it canceled for this term, but now it's back to do this multiplication with this term. So the x minus 3's cancel. So I have 2 times this 3x, which is 6x. So it's minus 6x. Okay, again, the x minus 3's cancel. So I have 2 times 3x, which is 6x, and of course don't forget that that's a minus. Equals, now over here I got to multiply all this, and this is in the way, but anyway, I've got x times 2, which is 2x, times the x minus 3. So I'm just going to have to distribute that. Okay, so I got 2x times x, which is 2x, and I've got 2x times negative 3, which is negative 6x. All right, there we go. Okay. All right, so now we've got this equation here, and notice now all the denominators are gone. And that's what we do when we solve this. We want to multiply to get rid of the denominators. And now all the denominators are gone, so we can add like terms and stuff. So, oh, wait a minute, I made a mistake here. This is 2x squared. I don't know if I said that, but didn't write it. I just noticed that 2x times x is 2x squared. I didn't write the square. Okay. So on this side right here, I usually have, I start with the highest powers. So the x squared term, there are none but that one. So I got a 2x squared here. And then I've got a negative 3x minus 6x, that's a negative 9x. And then I got this negative 9. So there's all my like terms combined there. Over here, now these are not like terms, so just leave it like that. Okay. And see, I got x squared here, so I'm going to have to get them on one side. So I'm going to have to minus 2x squared. And this cancels off. And it cancels off over there, too. And then, let's see what we got. We got negative 9x, not plus, minus 9 equals negative 6x. Okay. So, I tell you what, I got x's on both sides, and I got this 9 here. So I'm going to go ahead and move this over to the other side, since I got that 9 on this side. And then to make this go away, I've got this negative 9 equals, and this is going to be a 3x. Negative 6 plus 9 would be 3, and then I can divide by 3 on both sides. And that's going to be negative 3. Okay, so there's my solution, but now I got to come back up here. And look, now x can't be 3. Well, that's okay. This come out negative 3, so we're good. So this is the solution here, negative 3. Now, had this come out to be 3, and I can't have 3, then that means there'd be no solution at all. But we're good here. We got a solution negative 3. And let's see, did we get that right? Yeah, I think so. Negative 3. All right. Let's do another one. Okay. Solve this equation here. Now this one, in the denominators, they're the same. So this may be a little bit easier because it just has the same denominator. So, all right, first of all now, well, I'll write it out. X minus 3 equals 3 over x minus 3 plus 4. All right, so looking at this, I'm going to add 3, divide by 1, which is 3. X cannot be 3 again. X cannot be 3. So we have to keep that in mind. If I happen to get 3 for a solution, then that means there's no solution. All right, well, on this one now, that's my only denominator, so I'm going to multiply both sides by x minus 3. Okay? So I can get rid of these denominators. All right, so here's my equals, right? So when I multiply here, these cancel, and I have just x. Okay? When I multiply over here, I got to distribute to both of these terms. So when I distribute to here, that's going to cancel this. Now, I'm not going to mark it out because I got to do it here, but it will cancel this off, and I'll have just 3 plus. Now, when I multiply here, I got 4. This times 4, so I'm going to have to distribute. 4 times x is 4x. 4 times negative 3 is negative 12. All right, there you go. There's my equation, and it's got no denominators now. So that's what we want to do on this. Multiply and get rid of the denominators. Okay, now I've got like terms here, so I've got x equals 3 minus 12 is negative 9. And the 4x has no like terms to go with. And now, since I've got the x's on both sides, I got this 9 here, I need to move that over there. So the 4x minus 4x goes away. 1 minus 4 would be negative 3x. And then I'm going to divide both sides by negative 3. And this comes out to be 3. X equals 3. Uh-oh. Whoa, wait a minute. Wait. We can't have 3. We got 3, and we can't have 3, so this is no solution. No solution at all here because we got a value that makes it divide by 0. And sure enough, that's what it says here. It's an empty set. The solution is the empty set because there is no solution. Okay. All right, here's another one. Let's do this one. We've got 8 over x squared minus 1 minus 4 over x minus 1 equals 7 over x plus 1. All right, now this is like what I was telling you. I got this x squared minus 1. Now this is actually called a difference of squares. I got x squared and I got 1 squared, which is still 1. but that's going to be x minus 1 and x plus 1 multiplied together. So whichever way I look at it, x cannot be positive 1 and negative 1. See, negative 1 divided by 1 is negative 1. So 1 or negative 1. All right, so here's what x cannot be. Okay. Now, so we're going to multiply both sides by x minus 1 and x plus 1. Okay, so I'm going to do x minus 1, x plus 1. Multiply both sides by that. Okay, get it centered up a little bit. All right, so let's multiply. So when I multiply this to here, to this first one, well, these two, that's x squared minus 1. And it's going to cancel this, so I just have an 8 here. All right, when I multiply to this one, the x minus 1s will cancel, so I have x plus 1 times a negative 4. Now, don't forget this negative in front of that 4. So let me write that out. I got x plus 1 times negative 4. So it's negative 4, x plus 1. So it's going to be x times negative 4 is negative 4x. All right, so it's going to be negative 4x. And then 1 times negative 4 is negative 4. All right, there we go. Equals. There's my equals. Now over here on this side, when I multiply, these cancel. So I have 7 times x plus x minus 1. So 7 times x is 7x. 7 times negative 1 is negative 7. All right, so there we go, man. And now look, there's no denominators at all. We got rid of all of them. All right, so we can add our like terms. 8 plus negative 4 would be 4 minus 4x equals 7x minus 7. Okay, and so let's add 4x to both sides. To make that go away, that gives us 11x minus 7 equals 4 over here. Okay, and then I'm going to add 7 to give us 11 equals 11x. And I'm going to divide by 11 now, and that cancels off, and I get 1. There's my solution. X is 1. Okay, hold on, wait a minute. We said x cannot be 1 or negative 1. So we got an empty set again. It's empty. Can't have this solution because it makes us divide by 0. Okay. All right, now. So we'll do the same thing here. I'll leave this one for you to try doing, but here's my answers. Now this has 2 answers, 3 and 7. So 3 and 7. Oh, maybe I should do this one. I think we're going to have to do the quadratic formula on this one. So 2x minus 7 over x equals x minus 4 over 3. Okay, now right here, x can't be 0. Right there, there's no variable, so we're good there. But x cannot be 0, so we got to keep this in mind here. All right, so x and 3, I'm going to multiply both sides by 3x. Okay. When I multiply here, the x's cancel. Okay, the x's cancel. So I have 3 times this, so I'm going to distribute. 3 times 2x is 6x. 3 times negative 7 is negative 21. Okay, over here on this side, when I multiply, well, the 3's will cancel. So I have x minus 4 times x, which x times x would be x squared. Negative 4 times x is negative 4x. And there you go. We got an equation here with no denominators. All right, and let's see here. I got this x squared, so I think what I'm going to do, I'm going to move this stuff over here. Since it's a positive, I really like for my x squared to be positive. So I'm going to subtract 6x, which makes that go away. And I'm going to add 21. I'm going to go ahead and do that too, make that go away, so I equal 0 now. Okay, because I have x squared. This is a negative 10x, and that's a 21. And there you go. We've got us a quadratic equation. So we're going to have to do the quadratic formula. So if you remember now, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now let's put our values in right there. A is 1. Remember that 1 goes here and here. B is negative 10. We're going to put some negative 10 here, a negative 10 there. And then C is 21. It's all the way at the end. Okay, and then after you do this, hopefully you're getting good at this. There's 1, 2, 3 things to do here. All right, so right here we got 2 negatives. That's going to be a positive 10. Down here, 2 times 1 is 2. And then in my radical, all right, let's get my calculator here to help us out. Oh, excuse me. Negative 10 squared minus 4 times 1 times 21. And that is 16. Okay. Now we look at our radical, and the square root of 16 is 4. So this is going to be 10 plus or minus 4 divided by 2. Okay. Now 10 plus 4 is 14. 14 divided by 2 is 7. 10 minus 4 is 6, and 6 divided by 2 is 3. So here's my 2 answers right there for x, 7 and 3. And of course, x couldn't be 0, so we're good as far as that concerns. And that's why we have 7 and 3 as our 2 solutions. Okay. All right, now, this next problem we have. Sally can paint a room in 8 hours, while it takes Steve 7 hours to paint the same room. How long would it take them to paint the room if they work together? Okay, how long would it take Sally and Steve to paint the room if they work together? Okay, well, let's look at it like this. We've got Sally, we've got Steve. Sally can paint the room in 8 hours. Okay, well, how much does she get done in 1 hour? We talked about this a few minutes ago. Well, she can get 1/8 done. So she can get 1/8 of the room done in however many hours. Okay. Steve can paint the room in 7 hours. All right, so that means he can do 1/7 in an hour. Okay. Now, so how many hours must they work? So x is how many hours they work to where they have one full, complete painted room. So this is how you would set it up. Okay. So, or what you could do, this is 1x over 8 plus 1x over 7 equals just a plain 1 over there. And now you can look at your denominators here, 8 and 7. There's no variable in there, so you don't have to worry about our zeros. But my common denominator would be 56. Or I could just leave it 8 times 7 if you want to. 8 times 7. So right here, I'm going to distribute this. So when I distribute here, the 8s will cancel. So that's just going to be 7x. When I distribute to this one, the 7s are going to cancel. So that gives me 8 times x. Over here, 1 times 8 times 7 is 56. Okay, so now these are like terms. 7 plus 8, that's 15x. Okay, and then divide by 15. 56 over 15. That's how many hours it would take. 56 over 15 exact. Now if I do this, 56 divided by 15, it comes up to 3.73 hours. 3.73, so it kind of makes sense. But I think they just want it as a fraction like this, and you can see right here, that's what they have for the answer. Look at this next one here. A winery has a vat with 2 pipes leading into it. The inlet pipe can fill the vat in 7 hours, while the outlet pipe can empty it in 9 hours. So I guess what you have is you got this big old container. You got a pipe coming into it, okay? And then you got a pipe coming out of it. Okay, and so this pipe right here can fill it in 7 hours, while this one here empties it in 9 hours. Okay, how long will it take to fill the vat if both pipes are left open? So what we have is this. The one that fills it fills in 7 hours. So how much can it do in 1 hour? All right, it fills. Takes 1/7. It does 1/7 per hour. And then the empty one, it does it in 9 hours, so it's 1/9. But it's emptying, which means it's a minus. Okay, so it empties 1/9 of it per hour. Okay, so I'm going to do like I did a while ago, 1/7 times x plus, or since that's negative, I'll just make a minus right here. 1/9 times x equals 1 whole complete vat. All right, so it sets up the same way as the previous problem, but this is a minus because it's emptying it, it's not filling it. So that means 7, and this is going to be x over 7 minus x over 9 equals 1. See, 1 times x is x over 7. 1 times x is x over 9. And so 7 times 9 would be my common denominator. This is going to be 63. But when I multiply here, the 7's cancel, so that's going to be 9x. When I multiply here, distribute to this one, the 9's are going to cancel, so that's going to be 7x. Over here, that's going to be 63. And then these are like terms, so 9x minus 7x is 2x. And then I divide by 2. 63 over 2, which is 32.5 hours. But it says 63 over 2, which is what it wants, is a fraction. It wants an exact solution. Okay, so that's our rational expressions. Then we're getting into the radicals. Okay, solve this equation right here. Solve this equation. All right, now, when you have a radical, like the square root of something, square root of x equals, I don't know, 3. Okay? To get rid of the radical, you have to square both sides. Okay? And then the square will cancel the radical, so x would equal 3 squared, which is 9. Okay? But there's some kind of problem that happens sometimes, which we call extraneous, I don't know if I'm spelling this right, extraneous solutions. Extraneous solutions. What that is if you take two things that are not equal, like 3 does not equal -3. But if you square both of them, 3 squared is 9, -3 squared is 9. You make them equal. So this is what an extraneous solution is. When you take two things that are not equal and you square them and you make them equal. That happens sometimes when we solve these. So every time you solve these, you have to check your answers to make sure they're good and not extraneous. All right, so look at this one here. We got x minus, in the radical here, 3 minus 2x equals 0. Okay? Now what we're going to have to do is we're going to have to isolate our radical. And one thing I noticed, since this is a negative in front of my radical, I'm just going to add it to both sides. So this will cancel off to make it positive. And so it's 0 plus this, which is just this. Okay? And now, once I have my radical isolated, which isolated means it's all by itself, then I can square both sides. Okay? And when I square this, it cancels my radical. So I have x squared over here equals 3 minus 2x. And the square cancels the radical, so I just have the 3 minus 2x. Okay? Now, since I have x squared, I need to get everything on one side set it equal to 0. So I'm going to minus 3 on both sides to make this go away. I'm going to add 2x on both sides to make this go away, which gives me x squared plus 2x minus 3 equals 0, and there's a quadratic equation. Okay, so we're going to do the quadratic formula. All right, so I'd love to sing this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so my a is 1, so 1 and 1, those two spots. My b is a 2, 2 goes here, 2 goes there, and then c is a negative 3, and that's all the way at the end. All right, then we have, again, 1, 2, 3 things to do here. All right, so that means x equals negative 2. Down here, I got 2 times 1 is 2. And my radical, 4 plus 12 is 16. Okay, I just did that in my head instead of using the calculator this time. Now, the square root of 16 is 4. All right, so this is a negative 2 plus or minus 4. Okay, and now I can do my two answers. So negative 2 plus 4 would be 2, and 2 divided by 2 would be 1. Negative 2 minus 4 is negative 6. Negative 6 divided by 2 would be negative 3. So here's my two answers right there. Okay, but it's possible one of these is extraneous. Heck, it's possible both of them are. So we need to check both of these solutions. All right, so I need to put them in the original problem. So if I take 1 and put it in the original problem up here, all right, 3 minus 2 times 1 is 2, so 3 minus 2 would be 1, so that'd be the square root of 1. And so I have 1 minus 1 equals 0. That works. Now, if you need to, just use your calculator. Just put it in the calculator. We'll do it this way. So I'm putting 1 in for x. So I got 1 minus, and then I got my radical. And then I've got 3 minus 2 times 1. See, I get 0. So that one works. What about negative 3? So I put negative 3 in for x. So negative 3 minus, in my radical, I've got 3 minus 2 times negative 3. Oh, look there, I don't get 0. I get negative 6. So this one's extraneous, so we got to take it out. 1 worked, but negative 3 didn't. You got to check them, because sometimes one of them's extraneous and sometimes both of them are. And then sometimes neither one of them are. So you got to check them. Okay, so we'll do another one like this right here. Okay. So I've got the radical 7x plus 56 equals 2x plus 9. All right, so my radical is isolated this time, so I don't have to worry about getting it isolated. So I'm gonna square both sides. When I square here, it cancels the radical, so I have 7x plus 56. When I square here, all right, this is 2x plus 9 times 2x plus 9, so I'm going to have to do a box to do this multiplication. 2x plus 9, 2x plus 9, this is going to be 4x squared, 18x, 18x, 81. So this is going to be 4x squared, 18 plus 18 is 36x, and then plus 81. So I did it kind of fast, but all right, so, well, I got x squared. So I'm going to have to do quadratic formula. So I'm going to have to minus 7x on both sides. That makes this go away. I'm going to minus 56 on both sides. That makes this go away. And I've got 0 equals 4x squared. 36 minus 7 would be plus 29x. And then 81 minus 56 is 25, I think. Okay, and there we go. So we're going to do quadratic formula again. All right, my song. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, my a is 4, so that goes here and here. B is 29. I got a 29 here and a 29 there, and then C is 25 down here at the end. And then there's 3 things. 1, 2, 3 things to do here. Look at my color. So that means I got a negative 29. And here I got an 8. And then in my radical, all right, I'm going to get the calculator out here. 29 squared minus 4 times 25. Oops. Didn't get my parentheses in there. All right, so I think I'm good now. 441. Okay. Now I do that radical, so I'm going to go ahead and hit the radical of that answer. All right, 21. Good. All right, so it's negative 29 plus or minus 21 divided by 8. That's what x equals. Okay, so I do negative 29 plus 21, which is negative 8. Negative 8 divided by 8 would be negative 1. Negative 29 minus 21 would be negative 50. Negative 50 over 8. Okay, which that's negative 25 over 4 if I simplify it. Okay, so there's my solutions, but I gotta check them because it's possible they're both extraneous, or one of them is, maybe, I don't know. So I'm gonna have to come up here and put it in. Now this might be a little bit sticky, but I'm gonna put negative 1 in first. So I got this radical. All right, so let me clear this off. I got my radical. 7 times negative 1 plus 56. So I put my negative 1 in here, and it gives me a 7 on that side. So let me write it down. I'll just leave it on the screen. I got 7 on that side. Now I put negative 1 in here. Now remember, the square is not part of the original problem. So I'm going to do 2 times negative 1 plus 9. And I got 7. Look, I got 7 on both of them. Uh-oh, what went on there? So negative 1 works. So negative 1 is a good solution. Now let's try the negative 25 over 4. All right, so clear this off. So I got my radical. I got 7 times, all right, so it's negative 25 over 4. And then plus 56. All right, so on this side I got 3.5. All right, now let's put it in here. 2 times negative 25 over 4, and then plus 9. Oh, I got negative 3.5. I got the opposite, so that didn't work. That's extraneous, so this one's out. This solution's out. Negative 1 works, but that one doesn't. Okay. All right, here's another one. We'll do it the same way. I'm going to have to go on because we're about out of time. 17. Here, hold on. Go back to this one. Here's this problem here, and here's the answer. You can pause it and see if you can do this on your own. Okay. Now, this is the last part here. We got 3 more problems left where we're doing rational exponents. So on this one here, we got x to the 3/2 power equals 125. Okay, x to the 3/2 power equals 125. Well, it's x to this power right here. What we can do is we can raise this to another power, and I just flip it to the 2/3 power. 2/3 power on both sides. And when I do that, see, the 2's will cancel, the 3's will cancel. So it's just x. That's how you solve a rational exponent, is you just do the reciprocal of it. You do that exponent on both sides. So these will cancel. When I do the exponent of the exponent here, I multiply, and that cancels. So I do this to this exponent 2/3. So I'm going to bring my calculator in here. Okay. I'm going to do 125. Here's my exponent key. I'm going to do 2 divided by 3. And check it out, 25. There's my solution. So you can see that right there, 25. Okay, what about this next one here? I've got x squared plus 24x to the 1/4 power equals 3. Okay, well, see all this to the 1/4 power? So what I'm going to have to do is I'm going to raise it to the 4/1 power, which is the 4. Okay, when I do this now, this will cancel. So I have x squared plus 24x equals 3 to the 4th power, which is 81. And look here, I got x squared, so I'm going to have to minus 81 on both sides. Set it equals 0, because this is quadratic now. All right, so here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, my a is 1, my b is 24, and my c is negative 81. Okay, x equals negative 24. 2 times 1 is 2 down here. And my radical, let's try to punch this thing in, 24 squared minus 4 times 1 times negative 81, 900. Okay, now the square root of 900, and we'll go ahead and hit that, 30. All right, negative 24 plus or minus 30 divided by 2. All right, so negative 24 plus 30 would be 6. 6 divided by 2 would be 3. Negative 24 minus 30 is negative 54. Negative 54 divided by 2 is negative 27. So here's my two answers. Okay, but we didn't do extraneous solutions on this, I don't think. So I think we are good on that because we didn't square both sides. So, yep, negative 27 and 3. Okay, now one more here. X minus 7 to the 2/3 power equals 9. Okay, so we're going to do this right here, 2/3 power. I need to get rid of, so I'm going to do the 3/2 power. And when I do that, the 3's will cancel, the 2's will cancel, and that'll go away. So I have x minus 7 equals 9 to the 3/2. All right, so I can punch that in. Look here, 9 to the power of 3 divided by 2. And look at that, it's 27. Okay. All right, now here's one thing here you got to look for, and I almost didn't tell you. When this bottom number, when you do this on both sides, this exponent, this bottom number being, if it's even like this was, that means it could be positive or negative because we're doing a square root is what we're doing. So this could be positive or negative 27. Okay? So you got to watch out for that. These other problems we've done, none of the bottom numbers were even, so we didn't have to worry about this. But this is the first one we have like this. When I do this on both sides and the bottom number, when I do that on both sides and that bottom number is even, it could be positive or negative. So now finishing up, I would add 7. So I've got 27 plus 7, which is 34. But then I have negative 27 plus 7, which is negative 20. So that should be my two answers, and you can see it right here. Okay. Now, so I think we've gone through everything in this. This is other types of equations. So hopefully you can get through this. And if you have any questions, just give me a shout, okay? And I hope you have a great day.